Okay, this is Derwin King with ELC 215, Electrical Maintenance for Automation Systems. This Sampson Community College, February 11th, Thursday night. And we're going to be on station 4 where the shafts are, doing some measurements on some proximity sensors, inductive proximity sensor and a capacitive proximity sensor. I'm going to move this cart over that way. And as a matter of fact, I'm going to have to disconnect the VGA. We ain't got to have that up there no way for what I'm doing right now. We just got to, I got to have zoom though. So I'm going to move this so I can move that over. We can look at our schematics and not have to see them on the screen. And I should have enough charge on here to be able to roll it and not have to have power right now for at least a little bit. Okay, so let's get this thing over here. Okay, so the focal point here is going to be we got our station 4 schematic right here. So we're on page 4. You've got an inductive proximity sensor that's here, there's a picture before on it. Normally open, that's this one. It picks up metal only. This here's the capacitor, it's got a little capacitor sample in there. It's that big one. It picks up metal and plastic. Or your finger, it picks up anything. I mean, it'll pick up power, it'll pick up anything. I'm serious. It's got substance to it to pick it up. So I'm going to shoot this in here. Whoever's watching, we have an inductive proximity sensor there with the coil symbol normally open. We're going to measure going into the PLC here, where it says metallic shaft protection. We're going to check this one with plastic and metal. And then the one, the capacitor type, it picks up all shafts, plastic and metal. We're just going to measure the input there in different situations. So you go ahead and take one in. So what we saw, we measured metal here and plastic there. So this index till we get plastic here, we can get a different reading there. This just happened with the air. Matter of fact, including all of and just hit stop. Hold. So we're sitting here. It has an index. We still got metal and plastic. We got plastic over here, and then we'll get a measurement there. Actually, rotate it till you get that plastic and that metal one over here. Then you'll have plastic and metal. Then we can get the other two other readings we need. Then we'll do an index. You get those two over here. And what you can do is, look, you can grab them as soon as they come out of here. As soon as it releases to here, you can grab it and then pull the shaft out and cycle it back through it. It ain't even got to go no farther than this. actually put it in all of them. Just hit stop the front at the right time, but when you get plastic and metal, it's when you stop. Yeah, the gloves right over there, everybody's just get there. Now, you want that one here and this one there. That's gonna give us the other readings that we didn't get the other day. All you gotta do is pull the shaft out, the cover, and then let it go. That's it. That's all you gotta do. All we wanna do is just keep this one here satisfied, keep it running. It is. It is. Exactly. So, hold it just right there. So now, if you notice here, this is width, the work is not width, right? It only picks up ferrous metal, so it's just picking up metal. And this one picks up plastic and metal. While you had metal, and that's got plastic. And as you see, it's width down in the cover. It gets the LED width. So a couple of things you can notice here is, if you were troubleshooting and after the pressure's on your lamp, if you want to know, is that signal getting in there? All you've got to do is go where it says data.2 and data.3 on that address. And it says slot, well, actually slot 2. This gives you a different slot number to look at now. You got your schematic, make sure you got your schematic in front of you.
You have your mind. Here. Can you have your mind?
Yeah. You need to see what the address is now.
Thank you.
Yeah. So everybody get your schematic for station 4 and look at it. You notice it says local 2, not local 1. That means it's in slot 1. It's got an extra model in that slot 2. Slot number 1 and slot number 2. But they have an extra model added on to the basic PLC. This PLC doesn't have that extra model, see it. There's an add-on, so they didn't have enough inputs. They needed more than 16 inputs for this machine. Because there's so many sensors in there, 16 on enough, so they had to add another card in, which is slot 2. You notice here on this schematic, look on the schematic real good. Every address on there says local 2, and then I, and so it's slot number 2, I for input, and then data.0, data.1, so on. Everything in here says local 2 stuff. This dash block here is the second module in the PLC slot. That is the second module. If you back it up one page, because it's a 2, right? Because it's a 2, it's the second slot. If you back it up one page, what you see, it says local 1, right? And everything on page 3 says local 1, I for input, data.whatever. And it goes across that entire block is slot 1. It's actually half of slot 1 because it's input 8 through 15. If you back up to page 2, you'll see the first part of slot 1. So page 2, it has a local 1, I, data.0 through data.7. So page 2 has input 0 through 7, which is the first 8 inputs in slot 1. The next page gives you the next 8 inputs in slot 1, which is inputs 8 through 15. You see that? But you see when it says local 1, local means this. That slot is up here with the CPU. It's not in the remote I/O chassis behind the machine. It's not behind here with the remote I/O. Now, after it, if it says anything other than local, the remote I/O chassis is labeled like for power control. It's called power control. But they named that Ethernet adapter right there. When you see the software, it'll say power control instead of local in the address. And then there'll be some numbers after that for that chassis back there. You'll know it when you see it, but it's not local. Okay. It's important when you're trying to figure out, well, you could easily by mistake go to slot 1 and start checking, and you're not even supposed to be in slot 1, you're supposed to be in slot 2. But if you look at the address, This type of address scheme is for Studio 5000 software. So like you learned last summer online, it's that same terminology there. So a quick way to know if these signals are getting in without doing anything else, it simply goes to that slot number 1 and look at the LEDs on the phone. So you're looking for LED 2 on the input in this spot. And the inputs are in the book. What? I'm sorry, yeah, I'm sorry. Slot 2, yeah, I'm messed up there. If you look at the slot 2, and then LED on the first one. So it's the input 2 line. So he sees the LED on the front of the PLC, and you know it's on, and we get ready to find out what voltage it is. Is the voltage 24 volts? Is it what? And this, we know it's going to be, but we're going to measure that. Because sometimes it may be a little low, if something's wrong with the wiring, or, for people with a power supply might be really weak. So let's get the meter, let's get the voltmeter, let's measure those to the input. Now this time, you can go right straight to the monitor and read right off the input because we got screws there. Okay? So, let's see, where's the meter at? I thought I brought the meter over here. Yeah. Technically, we have them going on because you got stuff out of 50 volts that are this nearby there. And this here is included. It's a hassle. It is one hassle having that stuff on, but it's supposed to have it on. And that coach, if we're super careful, that coach's going to switch your depth in here. But we'll try to be super cautious with what we're doing here. Now, so we're going to go straight to the PLC model this time because you don't have to go to the script. This here you can't plug it because the switch you can do it. So it's super easy there. You want to find. You can check common wire number 25. Find wire number 25. You can also go on the door and look at the common. This is common on that door and take the key. I like those models better because you can go right to the plug. You don't have to go to the street, you go right straight to it. So you can you look at the wire number I-18, and then wire 25. When you download that door, you see that door here. Let's look at the input. It's actually input 2. So we're going to go over here. It was first to the bottom, right? On the left look. And you got it. See how you can't right off that doorway? Off that doorway, that's 23 volts there. That's because you got metal that's under that top. If that's true, it's about every day, you got that 23 volts there, you do it, okay? Let's check the capacitor one. It's also on this thing for back to time that. It's going to be, input 3. Input 3 is wire number I-19. And then come. 24 volts, that's it. That's it. You can come on that, write your numbers down. Very good. You come up in pairs and do it, it won't take you but a second. Once everybody does this, we're going to index the work completely empty with nothing in it. You'll see that there'll be 0 volts, or it's supposed to be 0 volts. And sometimes, listen, I'm going to tell you right, sometimes these things these sensors right here, what can happen to them, and I've seen it happen. I have seen it happen.
They get back off the
Well,
floor.
on the end of it, see, look up there, you see a gap in there?
Yeah, it should be back to the, of your license. Let's be
You
back.
see a little bit of light in there, a little bit of light, okay? But they got it so that when that part comes around, when the part comes around, it's not touching, it's close to it, it's not hitting. If this gets loose, and walks down, it stays. If that sensor stays by that part, and the face of that sensor gets rubbed off, you're gonna see a little copper coil in there exposed. This thing can short out and stay on.
Oh,
Or they can short out and blow a piece or something like that.
I'm seeing it get broken in half. I ain't seen that.
I've seen it get shaved by being too close and not having a cap. He's seen that. I know you have.
Yeah, we got them on our flywheels on the motors.
Mhm.
They got little holes cut out on them. They reach and it goes by. And we've had before somebody set it wrong, but it just breaks in half.
They can have. If you get it set close enough to where it shaves it like sandpaper, then the end of it ends up getting rubbed off and they end up short circuiting and stay on. So we want to see it after we do this. We want to see it look up and we want to see it cycle off. We want to see it cycle off and lose it. Okay?
Yeah, this one ain't easy to change out either. Is it?
It's just double nut. You loosen up the bottom nut, the top nut, and you just loosen it up.
I'm talking about if you were to change that whole thing, you have to get a whole case, or can you screw it right here?
That's the deal. They tell you, you got to trace it all the back of the tunnel.
Dang,
All the way to the home.
I probably if I read to fix that, yeah,
You have to come right through here.
I'd probably change the whole thing out, but when you can take the end off, that's what we have on ours, where you just screw them in and out. Yeah,
Y'all just kind of teamed up with somebody. Whoever didn't measure those, not measure, not physically. If you want to take them around, you go check this one here. If you love it, you will be wire number 18. You must get, you see the input two, negative two, look on that, so you find out the period. Almost the competition and go push. You see, you see two on here, okay? Then you're gonna go past this one. That's gonna be right behind that one, you input three. Input three. And you got 24 there on. That's right, that's it. And you'll fill in the spots, you just fill in the other line. For the metal here and plastic there, you got for the inductive, it'll be the metal part right here, 24. And then for the capacitor, it'll be plastic on this one, the plastic part. Right. Okay. I need to get can you help me have a cardboard box? Here's a box somewhere I have. I'm gonna set a box and put that camera on. Well, I actually got a spare one. Way back last year when there wasn't nobody in here but me. It was just me in here teaching this damn thing online. But there wasn't nobody in here. I have a question in the You'll see that input 2's on and input 3 is lit in the blue area. Input 2 and 3 are on the module in here. And that's indicating that the 24 volts is there, and he's just going to measure now. Meter. So if you can manage to do it to where this camera can see you. There's 23 volts. You've got 23 volts on that terminal. It's got level. It's supposed to be on. The other one would be I-19 where I-19 input 3. Y'all see it 24 volts? On the proper terminals there, that's good. That's it, you record your data, you did it, somebody else come up. When they index it in a minute, where there's nothing in front of one of them, you should see both of them go dead. Okay, next page. If you want to, it's super hot, but you got the good drop they bare minimum. Yeah. That's going to switch you up, man. It's really. If we were dealing with directly with the VFD, this got a 3-phase output. It's more serious. This one is second slot, input 2. That's exactly right. See that one? This is, that's, now let's index it around to where it's empty. So I'm gonna remove the parts that are in front of it, like this. And take that out. And we'll index it again.
That's all. Let me try. Oh, make sure I did it right. I didn't know what that second one measured was. I looked at it.
Well, you know, I brought 2 lines. I took 2 out right here. So we're gonna have 2 empty slots.
I don't tell them to get anything on.
I took 2 out right there.
Once they have something on.
So now let's index it again. And it needs a pallet now. So yeah, let's put a pallet in. What we're gonna do is see it rotate one more time, and then we can get the readings with nothing, without the part in there. And we're just gonna verify that the sensors are not stuck on, so that they can't see it. Okay, so right now, you don't have anything there on either one of them, so they should be 0 volt on 1 volt on the output. And why are we checking it? Because sometimes they ain't gonna be 0 volt, they may be stuck on. They might be short out. So that sensor does it something like it's supposed to. It's extended and back up, it's not going to continue like it's supposed to. That's the ELC good, it's supposed to be on certain time, and on certain time.
So you're saying, so easy. Yeah, I know. That's what I'm saying. You're saying it's supposed to be zero.
Yeah.
If there's an error there, it's like light, the sensor got stuck with something, then it would show a reading.
Right, if mainly if the face of it got rubbed, it got rubbed raw. So when you saw the coil, there's a pickup coil inside this thing. If you ever see one of them that's been shaved off, it's been hit too many times, there's actually a coil in there that looks like a coil in a relay. It's a sensor. The way these things work is like this. This thing's got a coil in it that radiates a magnetic field. And you got a magnetic field sitting there that radiates out. And the way it knows, the way that sensor knows if something's in front of the metal is that the metal actually, when it gets in front of the sensor, it actually distorts the field. It distorts the magnetic field that it generates. So it sets a field up there that's a certain pattern. And if you get something that comes into that field, it's like, I feel that, you know what I'm saying? It knows there's something there because it distorted the magnetic field. It's like if somebody comes up behind you, you feel something in the room that you don't, you know what I mean? You don't see it, but you can tell something. You know somebody come up behind you, you know what I mean? That's like it knows that. Huh? That's what I'm saying. What I'm saying is, you know somebody come in, but you didn't see it.
You take like a.
You know what I mean?
I use my.
It knows.
MVP card.
It knows that something is there, even though it
slide
can't see it. It senses.
And then I pull it out.
It senses it. In other words, it had vibes. It got the vibes off of this thing. This thing gives some different vibes.
They probably wouldn't pick it up.
That's about the way to put it.
Excuse me, Thomas.
This works on a capacitive principle. It's different. This is inductive. It's got a coil in there.
But if this one has those particles or anything in the reading, right?
Right. Yeah. I see.
We're doing a test for a minute. Yep, you're right. Yep. It's got to be within a certain amount of space.
You got a
It's
sense
a real small thing.
Typical on these, they got about a 5 millimeter gap on sensor things. You don't get something within 5 millimeters on.
Basically a credit card.
Then they won't pick it up.
Basically a credit card.
Now,
We said ours is 3.
look, you got a roll of electrical tape right here. I bet to take that up. Look in that light. You see that? There ain't no metal on that. That ain't nothing but tape. Now what? You see it pick it up? It'll pick your finger up.
Now, that would add.
I'm gonna put your finger in there now, but it'll pick it up.
That's the plastic one.
Yeah, that one's just as sensitive too.
It is, yeah. But hey, it picks up, and it may even pick up paper. No, there's not enough mass there. There wasn't enough mass to it. They had to have, I guess, more mass to it. If you roll it up, it may pick it up. You see that?
I got
the
it.
density of whatever it is, I seriously, it picked that paper up, you see that? Now look, if I go up close enough, it picks it up right there, got it right, so it knows, so it can pick up.
So now, on the density part, is that already figured into the sensor?
The way that you get this set is you loosen the clamp here, and you fine tune the distance to whatever the object is based on what that object is. You just have to fine tune that.
Well, no, I understand that, but I'm talking about the density.
Yeah, that's how they call it. So the sensitivity on it, the
Mhm.
distance is gonna be standard on those.
Oh, so it's already standard.
Yeah, yeah.
You
It-
just gotta figure out where it's gonna be.
Yeah.
You gotta move it closer. or
Okay.
You gotta, that's what the bracket's for. You loosen that up and it does. It does.
It does have a sensitivity.
That's something.
You can pull that little plug out there. Yeah, it's got a plug in it.
So it has a screw where you can change the
Pull that plug
sensitivity.
out.
Okay.
That's what I was
That's a
wondering.
little bit different, then, yeah.
See, that's what I was wondering. Because I have seen some where you take a little screwdriver.
That metal one, I know you can't do it on that.
I ain't never noticed it,
But
no, my.
Probably you can only do it on the plastic, not the metal. Metal's probably standard.
yeah, I'm not sure they might, and they have where you can adjust.
Yeah.
it.
Mine.
It's got, you see the hole down in there, the little arrow? I didn't even notice that, but it's got a plug. You can screwdriver, you can make it more or less sensitive, yeah.
Yeah, okay.
Did they see that?
No,
Did y'all see the sensitivity adjustment on this thing?
See, my question was,
You pull that plug out, it's got a screwdriver adjustment down in there, you can make it hotter or not so hot.
and Thomas said my
For
question was done.
distance. I'll give you an example. I'll give you an example where that would come in handy at.
He just found about me.
In Butterball, they told me in their gas stun, where they bring them turkeys through them in cages, in that gas stun area. They got them big old cages, and when they come in through that system to go in that gas stun area, they got to have sensors that pick up that that cage is there. It's there before it'll let it go, as it shovels through the conveyor system through the gas stun. They got them like that are big. It's got a 75 millimeter gap on them, 75 millimeter pickup range. And they got to have a wide range because the cage comes through there and slams, you know what I mean? They can't have that cage hitting anything. So it's got to have a real wide gap on it for the cages as they come through, because there's so much, there's a chance. You can't have something that's got to have a close range on something like that to do it, tear them all through pieces. So, anyway. But I got one in my office that's square, about that square and that big that they use on their gas stun cages. It's got a 75 millimeter range on it.
right.
So where these is about 5 millimeters. This one here, we have to look it up, and it probably tells you right under what it is. Well, it may. I bet I've got a data sheet on that in my computer, because they sent me a folder through the email that's got all your data sheets for everything that's and I can pull it up, find out what it is. But so right now, let's let you measure. So right now, input 2 and 3, they should be off. And they are. The LEDs ain't on. You can go measure voltage and make sure it's dead. You can just come by, put a meter on it and check. You don't even really need to measure it. Look, just look at the LEDs. You'll see the LEDs ain't on. Just come by and see that you'll see that they're dead here and that they're not even on here. Okay? 2 to 3 ain't on here.
It's gonna be
They're not
zero.
on. They're not on, so it's gonna be, just say it's 0. Okay? If they were lit, I'd be concerned. Then you would measure. Your concern right now is that if they were lit down there and they weren't lit up here, you got a short circuit somewhere in there, you know? No, you put 0 volts on that, you know? Exactly, see that? And look, that rotates, ain't no metal on that. See it coming out? Yeah, that's pretty slick. It's very, very sensitive. Very, very sensitive sensors. One of the things about the way the system's been set up, they put a variety of sensors in there so you can learn and get a little sample of some different kind of ways that things can be sensed. The next station is going to have a photoelectric that shoots a beam down and bounces it off of a part, and it gets a color recognition. It knows if it's light or dark color on the next station. So it's got something a little bit different there. Okay. So moving on. All right, now let's move on along here. So the last question. Okay, look, the question about number 8 says, explain the connection of the inductive and the capacitive sensors. So if you explain the connection, it's very simple. How you doing, bud? Okay, we're gonna cut this off. Let's see. Let's go. Sure. Okay, so look, this is for the inductive sensor. There was some print missing there. So on the inductive one, and you had without a part, with nothing in front of it, what you have? Okay, how about with metal? With the inductive sensor. The inductive one is the one that picks up metal. 24. And how about with plastic in front of it? 0. Now, the capacitive sensor, it picks up all of them. So if you have no part in front of it, what is it? 0, and then how about metal? And then plastic. Right, so that's part of their logic. Part of their logic is they got them different ones on there to help it determine what is on the machine. If one of them says, I see something there, I see a shaft of some kind, and the one before it said, I don't see anything, and then it indexes, and then the capacitive says, I see something, then it has to be plastic. You know what I mean? If the inductive says, I see nothing, and then it indexes the table, and then it says, well, and the PLC asks the capacitor, what do you see? It says, well, I see a shaft of some kind. I don't know what kind. And then the PLC does the logic that says, well, it has to be plastic because the inductive guy said, I didn't see nothing. So therefore, it has to be plastic. So that's how the intelligence of the machine is used, by having one that can sense one thing and one that can sense anything. You know what I mean? That's part of the intelligence part of it, that it's using different sensing devices to intelligently make decisions on what's there. No, it's okay. So we stepped the machine through. Now what we didn't do is I didn't give you the graph set for it. Let me give you the graph set. And this one is pretty amazing. And I want you to keep the graph set and come around the machine just for 1 minute. Just for 1 minute, I'll explain how to read this thing, because this is different than anything you've seen in this system at all. Get your graph set, let's get the machine again. Man, y'all come on here over here. Yeah, everybody come around, get you one of these, get you a grab. Get up time. You can hear about it, you can see what's going on. This is different. This is a whole different animal here. Yeah. Hit the gold button twice up there. Gold up front. 2 times. Yeah. Let's get this. I need me a wireless camera. That would be awesome if I had that. Let's get off of this. Now, let's go here. That's probably about as good as you're going to get right there. Okay, now, everybody got a graph set? Now, let's talk about the graph set and what does it mean? Everybody got the graph set in front of them? Do you have one? Okay. I'm trying to keep the wheels rolling here so we can. I was going to try to get you everything here tonight for the rest of the station so we can start the laptop too if you can. I was going to try to, if without going on too fast. Keep on scrolling. Everybody have one? You got your paper? Now, so let's look at here. Now, when you look at the graph set, whoever's out there, the graph set has some parallel logic sections in there, some parallel logic. What I mean by that is when the PLC boots up and it starts running the program, it goes into step 0, and when it leaves 0, if there's a pallet present, and if the no material, or if the initial conditions are met and there's a pallet there, it will go straight down from step 0, and it's going to go down to a junction point, and it's going to branch off, and it's going to initiate step 10, 20, 30, 40 at the same. Get 10, 20, 30, 40, and then flip over. It's going to initiate step 50, 60, and 70 at the same exact time. So what it does is, here's what a PLC can do that is common that can be done. Is you can initiate subroutines at the same time. You can have them turned on and enabled, okay? And so what you have here is, picture this. Let's say for step 10, it says feeding cylinder forward and backward, right? So look at here. This is simple. I'm going to break it down real simple. I'm a simple dude, and I looked how to break it down. First time I looked at this, I said, oh my goodness, man, what have I got into here? But the more I studied it, I figured out a simple way to explain it. Okay, step 10 and following is these pickers here. These pickers here, what they do is one of them extends and they always the opposite. And what they do is when it gets ready to drop apart, they will alternate like that and it'll drop apart. So the functioning of the drop on the hopper here is section 10, step 10, 11, 12, 13 is this device. Okay? you'll notice when this thing runs, this will be happening at the same time, but this will be happening, and it all kind of look like it's kind of at the same time, don't it? Because it pretty much is. So at the same time, step 20 is initiated, which is verification, cylinder downwards, and then cylinder forward. So the verification cylinder is this one. It goes down to what it does is there's a hollow cap in here, and if you can go down and straddle that shaft, it knows the shaft is oriented right. If this makes it down far enough, and this sensor comes on, it knows that the shaft is not upside down. If it is upside down, this doesn't come on, and it'll tell this to come down and get it and flip it. This will actually fix it if it's upside down here. I don't know if you've seen that before, but if you can mix them up and it'll straighten them out. Okay. So, and it does it by verification here. So that is the step 20, 21, 22. Okay. So that stuff in there has to do with this area. Cylinder downwards and forward will be up. It should be up, down, up instead of forward. So basically, this station is step 10 and following. This station is step 20 and following. And then the turnover manipulator, you see where it says turnover and gripper closure and all that. All that stuff in there, step 30 through 39 is this. So where it'll come down, grip it, come up, this thing here rotates, it'll flip, and then go down and let go of it. So if this tells this to flip it, when it gets here to go down and get it, come up, flip, go down, and then release it, come back up. So that's all of that stuff is in the 30 area, which can be happening at the same time as the previous step can be happening at the same exact time. That makes sense? It's called parallel logic in PLCs. You got multiple subroutines that's been enabled at the same time. They've all been enabled basically at the same time as far as what we can see. Now down on a millisecond level, it actually does execute kind of in a scan cycle. It all is literally not at the same time, but if it is happening so fast that we see it at the same time. Graphically, it's drawn at the same time. And as far as we're concerned, it actually, all of that is going on at the same time. We see the motions at the same time. Okay. Now, so this is step 30 through 39. Step 40 is the evacuation section, which is here. That's where if you have asked it to pass a certain part and reject other ones, that's when this thing will go out, down, and get it kicked down the ramp. So this whole deal here is step 40 and following. Okay, flip it around. And step 50 is the insertion manipulator, which is this. It's this mechanism here that actually goes, that gets the part, puts it out there in the block. It's all of the motions of this thing where it rotates and goes up and down. That's called the insertion manipulator right there. Okay? That's step 50 through 59. And step 60, look, step 60 is this sensor, the inductive detection. So if you get into PLC programming, the logic and the ladder logic, you find step 60, it's going to be where this is in the logic, the inductive system. And then step 70 is what? The capacitance detection, which is this. Step 70 in the PLC program, literally when you get into logic in there, which is going to be like next Thursday, you'll be looking at logic in these things, the ladder logic. Step 70 is where you can view and see the PLC program, see this thing. You can see where the logic is. And where it says if there's no material or, and all that, it would branch off from that. So in a nutshell, what looks so complicated is actually not. It's basically like if you have 1, 2, 3, 4, see, 1, 2, 3, 4, 5, 6, 7, 8. You've got eight functions. You have 8 subroutines there that are enabled all at the same time. And none of them cares what's going on as far as they don't have to wait for something else. Now, this one talks to this one but this one and this one can run at the same time. You know what I mean? You'll see them, when you watch it run, you just see it all kind of chugging along like a sewing machine. And, so.
Can you flip that one?
Huh?
Can you flip it right there on the stage too? That right there, can you flip it?
Can we make it flip?
That way.
Yes, you want to see it flip? Yeah. So if it hasn't checked it yet, then yes, we could go ahead and do that, yeah. I don't know if it's checked it yet or not, but we'll find out. Just check it now. See, it's out of parts here, so I've got to reset and then do it again. So when it gets over here, it'll flip back.
You got to send another block out here.
Mm-hmm. Yeah. But then again, you see it go out and get in the wash. This means there's nothing here at all, zero. So you got to reset and then recock it. It'll come up, flip it, go down and get it, and it comes up. Yeah. So it's pretty smart. It knows. It knows what's going on. Yeah. It's slicker than onion there, ain't man. I ain't never seen nothing made like that. SMC's got some nice stuff, man. They do. I ain't kidding. They're smart cookies, man. They're smart cookies, they are. But you see how this paper's going to help you a lot. It's going to point you to what step to get to in that program to start looking at that problem when something ain't right. Make sense? Mm-hmm. You see all that going on, you know, that's where the parallel logic comes in. The guy that wrote the programming, he's a very intelligent programmer. I mean, you get into that program, man, that dude spent a bunch of hours writing this stuff. You'll appreciate it when you get into it. Once you study it and get into it, you'll have a real appreciation for guys that write the logic that big. Those of you that had ELC 128, when you get into this thing, it's like going to be going from a fish pond to the Atlantic Ocean, man. I'm not kidding you. You get ready to get out of the pond, we're going to the ocean, you know. I ain't kidding. We're going to go to the Gulf Stream. We're going to go to the Gulf Stream. You better get your big rod, yeah. Okay. So anyhow, that's this station. I'm going to give you the pneumatic diagram, and we're going to click onto this now. Well, I ain't going to discuss the pneumatic other than one thing. These pictures here, these pictures are plumbed in back. You keep the paper on that right quick. That's something that we do need to discuss just for a second. I got the pneumatic diagram out here with you. There's the pneumatic this station. I'm just going to point out one thing that's unique, and that's it. Notice here how your horizontal shaft through the cylinder is now a hose to the back of it. So one of them's out there. The cylinders are in parallel, but they're on opposite parallel. You want that part? Now, very briefly, we got two cylinders over here. The two cylinders that are right here, they're always opposite from each other, if you would. They're always opposite into those two. One of them's always retracted and one of them's always extended. So if you look at your piping there, you'll see it coming from the valve, but the E plus hose feeds the front of one, and it feeds the back of the other. See that? And then on the E minus hose, the E minus hose feeds the back of the bottom cylinder, but it feeds the front of the top cylinder. So watch the pictures when they hit. Let's index it one more time. Watch right in here. It's okay, I'm sorry. Yeah, I got the picture. I know it's right now. Just one more time.
You a little later.
Watch the. You see how they move. All those knobs. All those is the hose that you work on one.
That's to make sure of applicable.
In our afternoon class, we do parallel. Here they go, like opposing.
We heard about this.
That's the only thing different here. The rest of the stuff is the same. So we're ready to move over here now. The fire. Move myself back over here. Let's discuss question number 8 here.
Yeah.
Number 8, yeah. Let's talk about it. Yeah, give me a second here. Mm-hmm. Trying to work it out to where you guys get more troubleshooting right saying, you know. You'll have 2 months of troubleshooting. You know, I'm shooting for Tuesday, getting the laptops out, and then Thursday I can start giving you some bugs. That's okay. So we cycled it and we looked at the sequence, explained how the connection of the inductive and the capacitive sensors is carried out. That's very, very simple, but we do need to discuss it. So let me make sure to get my screen share updated here. It's a little bit sluggish. Now, so the way these sensors are 3-wire sensors. They're not 2-wire like the magnetic read. The magnetic read sensors have 24 volts coming in and 24 volts leaving. They don't require you to have a common on there for that sensor to operate, because it's just a magnetic sensitive switch. These are more electronic type that have to have a V plus and a V minus coming in. So if you follow this up, this is the 24 and that's the common, the 0 volt. that sensor has to have, and then it has an output. So those wires there, they come all the way over from here, and you know that's 24, and that's a common from the power supply on the first page. Okay, if you trace that back, wire 25 is a 0-volt common off of page 1. Without me going all the way back to that, you can look it up yourself and see that's what it is. So in industry, proximity sensors, most of the time are going to have 3 wires. You got 24 volt, a common 0, and then an output signal that is actually the 24 volt that comes from here. So when the inductive senses, that's the symbol for the inductive coil, the switch closes and it connects the V plus to the output, and then the PLC gets it right there at that input. And there goes your slot 2 that you were looking at, that you were in the second slot of the PLC. Okay? So all you got to say is, as far as the connection method would be, those sensors are 3-wire proximity sensors. They require 24 volts. They require 24 volt and a common to operate. And then they have a single output. You can even put the wire colors. You can say the brown wire is 24 volt, blue wire is common, and the black wire is the output. That's a way to put it. That's how they, you have to have those 3 hooked up for it to work. Yep. Now they do make these sensors in a 120 volt AC version. I've seen them that run on 120 volts AC, and they would feed an input on a PLC that's 120 AC. All of them are not going to be DC necessarily where you go to work at. The matter of fact, these suitcase trainers that are up here, these suitcase trainers, those micrologic PLCs, they're 120 volt AC coming in every input. So what you have there, everything on all the inputs and outputs are 120 AC on that PLC, on these suitcases. Right? That's just, if you can order that way, you can have a machine that way, but the 24 DC is safer. It's lower voltage, it's way safer, it's a lot safer. Yeah. If you look up here, the brown wire is 24 volt, the blue wire is 0 volt common, and then the black wire is the output to the PLC that's 24 volts also. It puts out 24 whenever it's on. Yeah. Yeah. Yeah, we were just explaining, guys, that well, he can. You want to catch him up on what? Over y'all? Did y'all hear it? Or how to explain how to hook up how the sensors are hooked up? Gotcha. Okay. All right. Okay. Cool. It's been a long day, hasn't it, man? I know it has been. Yeah. You probably didn't have something. But yeah. But you. I heard that barely. Yeah. Yeah. I kind of inhaled a salad. I inhaled it. I don't like eating salad quick, but I did. Now moving right along. So you explain that, and then we ain't gonna modify nothing. Ain't got time for that. Now this is kind of a different kind of question here, but it's simple. It's simple to answer. In the event of a power cut, the single solenoid valve will return to their initial position because their spring return. The movement made by the components governed by the solenoid valves can entail a hazard for the user. How can this risk be eliminated? So what they're saying here is if you got a single solenoid that runs, I'm just going to show you real quick here. A single solenoid would be like this. This is the F cylinder. The F cylinder is not energized with the one axis. And when the power goes out, it goes like this, right? It's okay there. Now, if it was something critical that actually get handled like some of the most like on the rotary. This rotary, when it goes out and goes down, you put more liquid, I'm gonna say you one that's like no soil on that. We're gonna compare single soil on this is here. Single soil, you put 24 just this, but the 24 gallons comes from. This one here is got a double soil, it's the seed. And I energize it. I energize it to touch my hand on it, all I do is focus it, and it just stays. That's a double soil on this, it's got a big end, and it's where you focus it, it goes fast. And watch this. If it goes down part is the piece. If it goes down, the power goes out, but here's the reason. This is if the sea still that comes back, while that's down, it can actually play something down there, you know what I mean? It can play something. But if the power goes out, look, if the power goes out, the sea still will come back, it's the same. This is the same as going on fire, because they come back, but we can't go real. But the sea silver did not go back. That's, but if you have a single formula on this one, you can see that happen. Like that. So, what you do is you got half, you got a single formula, and there's half involved. How do you change the situation like this? If you use a single soil on this, and if you go out there with three, what would you do if you have a single soil on it?
You have to produce them.
You put a double soil on it, yeah. That's what it looks for. If you have a single soil, and it moves half the wheels, stand up, you change that right to the double soil. You won't your hand, because a single storm is actually trying to run, even if you feel the air, even if you dump the air. Chances are, there's not really enough liquid in there, and that's playing, it's still going to breathe. Even if you dump it. Chances are, it's still going to come back, and it's not going to be anything good. It's going to be a single soil here for the dog. Where the pressure goes down and then goes back, that would be a big can of so this thing is don't use single soil, use the rubber. That's how I look at that. So it on, so it's going to wait. It has to be both come home on the sea here. There's a second motor by the way, and I know it's going to close the milk. My folks fly away. The folks will go out and stay. The folks that get over it, it's top. There's two folks on there, two others out one time. When you get that whole thing, you've got to stay. The folks out and the folks out and get the as far as you go out and stay around, you get your small. You have to go there. But you have to go there, I'll do something, you get out here, you don't do it. You come back and you get out. But anyhow, I want to stay in front of that way to this. That makes sense.
Any question?
I probably spend more time than I need to on trying to explain something than how I am. I kind of ramble. I kind of ran around that. All right. So that's everything on Station 4. Everything that we need to cover anyway. So then I'll start giving you stuff on 5. If y'all want to get a break in, that's perfectly fine. I don't want somebody thinking that I'm trying to like push too much. But that's pretty much it. If you want to get a break in, feel free to get up, and then I'll make my statement. We're going to focus on what is unique about that station. We're not going to talk about everything. We're going to talk about there's 2 sections on it that are different than any other station. We're just going to talk about those 2 as we move on. So, there. Do you want all your stuff for that station? You get ready to leave?
Yeah, might as well.
That's the record. We're working on right now. And that's all for that section. You just get 6 to come back. You won't read that in There's 4 schematics right there, you know. 1, 2, 3, 4 guys up there that don't have yet. 1, 2, 4. Okay. We're just going to look at what's what's new there, it's not on the other system.
Battery running low. I got you some stuff at 5. Mm-hmm. Let's see.
We're on,
So for station 5, let's just jump to what's unique. There's nothing. There's an extra module in there that's not mentioned here that you'll be getting into pretty soon. It's a new PLC module that's not on anything else. Here, we're going to skip this just for the moment. It wants you to get measurements off of a linear encoder that measures the height of the cat. It wants you to get measurements. We're going to use an oscilloscope to do it because it's an encoder, and you can't read an encoder with a meter, with a regular voltmeter. It won't read it because it's got pulses, fast changing pulses. So we've got a fluke digital oscilloscope that we're going to use to do that with. Because it has to be a high-speed screen that shows the pulse. A scope meter to read an encoder output. Scope meter. And you can read encoders if they're linear or rotary encoders like on motors. You can read servo output. It goes with this, it's a very fast system. This is the Mac band right here. This yeah. Get a paper itself, I'm quick. You got place to keep it, get a paper itself. Can you do two electric? Yeah. Yes, you will trace to the if I sit on the home. You can light up that line, it shows you the I'm trying to cool down before I can say two different signal inputs. The encoder got two different pulse outputs. Then you two different screens. Now, what do you think was happening after that? So we plug it in, we had a follow, right? We're probably better off discussing the schematics and then say for the next time. There's not
That digital scopes, you gotta have one of them to read the pulses, and then it's got a screen on it that'll read the pulses. And we use that too tonight. Yeah, but we won't, there obviously won't be time to, I just showed you what it is. Look at it.
We will save this for Tuesday. And as far as they want you to explain how the encoder is hooked up. So if we go to the electric diagram, we will look at that. So if I go to resync, going over to the next station. Now, so on the shaft station for station 5, you got the first page there. That's the main with the power supplies. You got some regular inputs with your push buttons and read sensors. You got another page with read sensors. And here, let's slow down a little bit. You got one new sensor here other than the encoder. It's a photo eye. It's got a photoelectric reflector. So let's take a second here. Now, if you go over here, you're seeing the same thing you saw on station 4. You got an inductive sensor and a capacitive sensor that are proximity sensors that picks up a metallic cover, or it picks up any kind of cover. So that symbol, you know what they are, okay? We go to the next page, and you're going to see a new type of a symbol that that'll go. Now, it goes a new symbol over here, and it's let's zoom in on that. Now, so this one also has a 24 volt, and then the common coming in, and then an output, a 24 volt output. So let's take a look at the symbol, a close up of it, and what does it mean? Right there. What this is it's a single unit reflective photoelectric sensor that sends out a beam out of it. It bounces off of an object and comes back in. So it looks for a reflection off of something, and if it gets the reflection back, then it knows as far as if it's a light color or a dark color object. Okay, so if you look at here, the arrow going out means that it has a light beam that shines out of it, and it hits something out here, and then it bounces back here. So it's got a transmit eye and it's got a receiver eye in the same sensor, in the same unit. To where some listen to here, anytime you have a garage, you have a garage door home where you can. The garage door has got a two-part sensor at the bottom of the door. It's got a transmit and receive that's a two-part send and receive unit that's a photoelectric. This thing will be the same thing that's all in one unit that those two get parts in one unit. And in 1 minute, it sends the thing out and it bounces off something and comes back. In the garage door, you have whatever that shines the thing in the eye of the other, like your remote control on the TV. Your remote control puts an infrared beam out and you point it to the television and hit a button. It receives and it has the eye on the television, it receives what you shot from the remote. And it changes the camera. So you have a photo eye
that on your, button, on the remote home, and still television package on the bottom. It's called a electric. It's the same way, but it's one piece, and you have to have a standard. It's always, it's just, I'm gonna say, in this kind of office, you can make out the open street, and that's what it is. That's what it is. Where it is, I'm gonna show you on the machine where it is. It looks like this inside. But if you can see the face of it, it was really, one half of the skin and the other was the tree. But it shoots the beam down and it comes back, it knows something about the soul of what's in front of it. That's how they check if it's a light or dark by the reflection that comes off of it. But it's a photoelectric sensor today. That one is in your, hey, go back to your study guide. And you can go ahead and you can put it in your study guide that's in there. You'll find it in there. So I'm going to scroll down and show it to you that it's in there. Right there. That's in your study guide. You can go ahead and put what that is in that study guide, okay? If you go back to your word bank, now you got the plus coming in, and then the common, and then the output normally open. DC. The word bank tells you a photoelectric sensor or detector. That's what it's called. Okay, everybody got it? So that's a sensor that we haven't seen yet. And so that's the one, one of the few things that we need to be looking at here. And then we zoom out. The rest of them are what you've been seeing. It's just a repeat of what you've been seeing. Now, this is something that's totally new. It's the encoder itself. That's mounted on the cylinder that does the measuring of the thickness of the cap. So if you go to here, there's a lot of wiring involved, but all I'm going to tell you is this. To sum up the connection of it, I'm just going to say a few things. Is that encoder, let me give you I'm going to give you a David, you know the encoder. If you look at this is the actual cylinder that the encoder built off the side. So this is the it's supposed to be cylinder designed by ELC. If you read the structure, it actually tells you it's got a magnetic strip on the inside. It's structured with cylinder. Now I'm going to point through it over here, guys, over here. I got my hand up. This is the cylinder. That little bar, if you look at this side, this is the built-in encoder, and it's structured with cylinder. That encoder is actually a part of it. It gets actually made up of wood in and out, and actually comes into that way. That cable feeds ELC, and the cable puts that square wave pulse, and it fills, you put pulse, basically, and it comes can't change the pulse. So what it does, I'll do it very briefly here. We'll use the oscilloscope truth bag to let you measure that. It pulls out pulses like this. So it pulls out pulses, and the PLC counts the pulses. So if the silver starts crashing coming down, it's putting these pulses out, and tells you where it is. And it tells you how far it's moving in pulse counts. So the PLC counts, it's got a high-speed camera and program, and when it gets to the bottom end, and it sees the clip, it calculates the height of the cap that it pressed on. That's how it calculates on that. For the other ones, when you're analog, there it's an encoder it's a different way of measuring something. It's a digital type thing. You'll see this on the oscilloscope where a regular voltmeter is going to reach that. It'll be a bunch of points that the meters where it's supposed to be invisible of that.
The connection of it is done like this. It's got 24 volts going to the encoder. It's got a couple of jumpers that it has to have. And it has two outputs. The encoder has an A phase and a B phase output on the encoder. It's got one of the outputs tells you the count, and then the other one, they use it to figure out is it extending or is it retracting. They use the A output for position as far as how far it went, and they use this output to determine which way it's traveling. Is it actually going out or coming in? And we'll get into that. You go this way. As far as the connections go, you just put down that it has to have 24 volts to power the encoder. It's got two outputs. The two outputs feed the PLC. There's a special PLC card. It's a high-speed input module that counts high-speed pulses. Actually, 8. Yeah, explain how the connection of the linear encoder is carried out. And we're not going to finish this tonight, I know, because it's almost time. But basically, let's get started with understanding the encoder. Let's just get started on it very, very, very slowly here. That encoder has to have 24 volt and common just to power it, to have it powered on. And then the encoder, it produces two outputs. It has an A and a B output that go into the PLC. Now I'm going to show you in this handout that I gave you, I'm going to show you a picture of what the outputs look like from this sheet here. So if you go to okay, if you look up here, this is the encoder that's actually permanently mounted on that cylinder with the cable coming out of it. And so let's look at the, I'll just show you what page that it shows you where the pulses are. It's on 10-12-5. And then that's about as far as we're going to get for tonight. And that's fine. I'm not going to go faster than I can think. You know what I mean? They're showing you applications of where this thing can be used. different things other than what we're doing for doing measurements, doing actual automated measurements. And now here, this is showing you here this is showing you the gist of how the encoder, sort of what it does. Over here, the measurement principle is like this. So focus on the left side here, and it puts out two signals. The A phase, it puts these pulses out. The B phase is actually 90 degrees behind the first one. And it uses this one to determine if the cylinder is going down or going up. It knows by reading that B phase, comparing it to the A, it knows is that cylinder going down or going up. It knows it by that, by how the pulses come back. Now, so it does put out square wave pulses that way, and they're counted by the PLC to know position. Now, the cylinder, this is a breakdown of the cylinder itself. So let's open this up. And here, with mounted on the cylinder rod, is you have a magnetic scale rod. And let's see if I can get, and you have a sensor head here. Let's back out some. Now, right here, this is where it shows you a better picture here of how it works. This gives you the real inside story of what's going on in this cylinder. Now, look at here. You've got the shaft, the piston rod actually has some notches cut out of it. It's been milled out, okay? It's got notches in there, and you have in there, you have a non-magnetic section. It has, you have a magnetic section in between and a non-magnetic section in here. So it has lots of little spots in there that are magnetized and not magnetized, okay? This is actually on the rod, on the cylinder rod. Then you have a magnet here and a magnetic resistance element and a magnet here. And as the rod moves, this thing picks up and it knows the movement of the shaft by this sensor here. It goes through amplifier interpolation circuit, then it goes to the counter, which is the PLC. But this thing puts out these, it puts out like a sine wave, and it puts two out. One of them is 90 degrees behind the other one. And when it comes out of the thing, when it comes out of the interpolation circuit, it turns it into square wave, to where it's sort of like this inside of it. What the PLC sees is when it converts the sines over to square wave, then the PLC is actually getting those two outputs, the A and the B, to where this is the main output, and then the B starts at the 90-degree point of the A every time. So these two signals are what you see coming out right here. So when it leaves the encoder, this is the A output and the B output. So you got the one that leads and the one that lags by 90 degrees is that second one there, okay? So this one goes into the PLC here, this one goes into the PLC there. And so we'll be getting into, so as far as the connection goes, it's got two outputs, an A and a B output. And then it has two resistors that have to be there for interfacing that are 470 ohm resistors that are required by the company. 470 ohm, those are resistors that are on the terminal strip over there that you can see. Those two are required. These two are required between the 24 volt and the output to let that brand encoder work with that PLC input card. You can just put down, it got two special interface resistors that have to be there that lets SMC encoder talk with an alphabet input card. Okay? That's about the best way to put it. Without getting into way deeper, a deeper explanation of these, but they take the 24 volt, they go through these resistors, and then they tie on to these outputs. It's a strange thing. They're called pull-up resistors. Now, for me to get into it tonight, there ain't enough time. It's an electronic term called pull-up position, but it has to have it there because of the type of outputs that encoder has. You don't have to understand the details of it, but you see here, them little resistors, I'm going to show you where they are. They're mounted, if you look on the last page, where it shows the terminal strips at, they're sitting right there. So if you look on the last page there, there they are right there on the strip. If you look close enough, when you get in front of it, you'll see them on there. There they are right there. They're little, and they're just screwed into the strip. Okay. Your concern with the encoder would be knowing how to use the oscilloscope that I just showed you, how to measure the output of the encoder. What we're going to do is this. Y'all take a look here. This scope here is called a fuel trace scope. It's got the red and the gray are two different inputs. It's got a split screen. And the red can read the contact in the picture up there, and the gray can read two different signals. You see the A and the B signals separately on two halves of the screen, and the black is the constant. So it's a fuel trace diesel scope. And it shows the picture of the signal. You can plug that in the wall and look at the sine wave coming in the 120. You can read that. But you have to do the signal point from motor. It'll read right now. We'll move it around and show you what does the wall look like? What does DC look like on here? So it's a good thing that I can use. You don't use this kind of thing all the time, but if you want a guy who knows how to use it, you'll be one of the few that can explain things and maybe solve problems very good when maybe nobody else did, It's got the two inputs here with the red and the dual trace with a common. So it has a split screen. So here.
No, we have planned for the President's Day. Yeah, President's Day.
Let's look on the calendar. Let me put it on the screen up there. I think so.
I meant to ask you earlier.
I don't think it's for that, but let's pull it up here and look.
I can pull it up here and tell you.
I don't think you do. You said we don't think you like that? No, I think you do. I don't think you have.
I'm going to end this session. Whoever's out there, good evening. Have a blessed weekend.
Please don't.